Hello and welcome to my YouTube channel. This is Ramani Online Mathematics. Please, if you have not subscribed, please try to subscribe for me. So we are continuing with the method of characteristics under the question linear. So let's look at this question. Solve the equation x u x. Let me write the equation here. So this is the equation you are going to solve. So we are using the method dx over a equals dy over b equals du over f. Our a here will be xu, our b here will be yu, and our f here will be u square minus 1. The x over xu is equals to dy over yu is equals to du over u square minus 1. So now, first of all, let's compare these two. We can solve it. So looking at this one, we have the x over xu equals dy over yu. So if I multiply both sides by u, the u will go away, leaving the x over x equals dy over y. So you can integrate this. Now if you integrate this, you have ln x. Okay, good. Ln x plus ln c1 equals to ln y. So ln x plus this will give you c1x equals to ln y. So you take natural log, that's the exponential e on both sides. You have c1 x equals y. So our c1 will equal to y over x. So let me write my c1 here, y over x. I'll come and use it later. Okay, now let's look at the continuity of it. We are now having c1, so we need to also look for c2. Okay, so for the c2, you can compare this to this or this to that, it will all work. So let me compare the x. So I have the x over xu is equals to the u over u square minus 1. This implies that you know that this one, if I multiply both sides by u, this u can come here. So that I have the x over x is equals to u, the u over u square minus 1. Is that okay? So in this case, we can integrate both sides. Now if we integrate the x over x, we have what? We have ln x plus ln c2 equals, this is going to give us half of ln u square minus 1. I hope you know why. This is a function in derivative, just that here, if you differentiate this one, it will give you 2u. So that 2 here is, when you factorize the 2 out, that will be 1 over 2 out, leaving u. That's why you get something like this. So in this case, this and that will give you ln c2x equals to half, let me even multiply 2 by 2, so 2 coming here, ln u square minus 1. So you know logarithm, these 2 can come here, so that we have ln c2 x square. The square 2 is affecting the constant, but constant square is still constant, equals to ln u square minus 1. So if you look at this, if you take the ln, so they will cancel out, leaving c2 s squared equals u squared minus 1. Therefore, C2 will be equals to u squared minus 1 all divided by s squared. Is that okay? So let me write this C1. Let me write my C2 here. U squared minus 1 s squared. Now, this one is not having u, but this is having u. So we are going to write C2 as a function of what? C1. So I'm going to have C2 equals f of C1. This implies that, okay, let me calm down. This, we have u square minus 1 over s square equals f of y over x. Is that okay? So this is what we are going to have. Trying to make u squared the subject first. So we are going to have u squared minus 1 equals s squared f at y over x. Is that okay? So that u squared is equals to s squared f at y over x plus 1. Okay. You can divide both sides by square root of, you can take square root on both sides. Okay, but for now, let's maintain this. This becomes like our general solution. But there was initial condition given, which is this. So let's look at the initial condition. So let me write my general solution here so that I won't forget. U square equals s square plus f at y over x plus 1. So that's my general solution. Okay, so if you look at this one, this is our condition, and this is the general solution that we have. So you need to find the particular solution. The meaning of this is that wherever you see u is x cubed, but this u to the power 2. So if I put x cubed here, that will be x to the power 3. So I have x to the power, x to the power 6. Already 2 is a 2 times 3, that will be 6. Equals, x is x, so I'll maintain this x squared f at y. Now in this case, our y is what? X squared dividing by x plus 1. So this is what you are going to have. So in this case, we have x to the power 6 equals x squared f at x, because x can go into x squared x plus 1. Let's make f at x the subject here. So if you make f at x the subject, what are you going to get? You're going to have x to the power 6 minus 1 all divided by x squared. So this is what we have. Now, the meaning of this is that here you can say that let p to be equals to x, but it's still x, so you can decide to forget about bringing the p. Is that okay? So the meaning of what I have here is that, you go back to the general solution where we have y over x. So means that wherever I see x is now y over x. So that's what I'm going to do there. So I have u squared. Okay, let me pick that one alone. If not, it will be confusing. So f y over x will be equals to, so here will be y to the power 6 over x to the power 6 minus 1 all divided by y to the power 6 over x to the power. So let me bring a division sign like this. Y to the power squared over x to the power squared, like this. Now here, if you find LCM, you know what you are going to get. So f at y over x will be, LCM will be y to the power 6 minus x to the power 6 all divided by x to the power 6 times s squared over y squared. Is that okay? Now in this case, this s squared, two of them will take care of this, so that at the end here we have y to the power 6 minus x to the power 6 all divided by x to the power 4 y to the power 2. So this is what you are going to have for f at y over x. So I'm going to replace that one here. Once I replace it here, then you have gotten our particular solution. So now f at y over x is y to the power 6 minus x to the power 6, all divided by x to the power 4 y to the power 2, like this. And remember, here is plus 1. But this x square will also go with this, so that at the end you are going to have y square equals, let me bring the 1 first, 1 plus y to the power 6 minus x to the power 6, all divided by x squared y squared. Is that okay? So now you can take square root to get our function u to be square root of square root of 1 plus y power 6 minus x power 6, all divided by x squared y squared. So this becomes our final answer to this question. Thank you. Let's move to the next question. Oh, okay. The 2 or the b, and this is supposed to be the b. If there a unique solution for the quality problem over the entire line? Yes, there's a unique solution over the entire line, except, so you can say that, so that is a b. You can say that there is a unique solution over the entire line, except x equals 0 or y equals 0. You know that if x is 0, it will be 0, it will be over 0, which is undefined, because 0 times y will be 0. That will be undefined, so that we won't get any solution. When y2 is 0, that will what will happen. So it will be, we have a unique solution over the entire line, except x is 0, y equals 0. Okay, let's look at the second example. Okay, now let's look at the second question. Solve the equation x bracket open y squared plus u close bracket ux minus y bracket open x squared plus u uy equals bracket open x squared minus y squared u, subject to the auxiliary condition u bracket open x comma 3x equals x squared. Is that okay? So we are going to solve this still under, we are using the method of characteristics. So in fact, I'm going to do everything here. If I get C1, I'll come and write it here. If I get C2, I'll come and write it here due to the size of the board. Okay. So let me start it from here. You know what the A is already. So the whole of this will be A. X, you know, the coefficient of U subscript X is the A. Coefficient of U subscript Y is the B. So the B will be negative of that. And then the whole of this become what? F. Okay. So we are going to have D over X bracket open y squared plus u, that's the x, then the y will be over minus y bracket open x squared plus u, and the u will be over x squared minus y squared u. So this is how you are going to write this. You should take note of that. Is that okay? Very good. So here there are a lot of things that we are going to apply, a lot, so you should take note of that. We are going to apply a lot of things. So you remember this 6 over 3. I did this in illustration to you. I mean 3 over 6. Why? To this is half. This one can also be written as 3 plus 1 over 6 plus 2 to get 4 over what? 8. It is the same thing. So that's what I'm going to use here. I'm going to add this one to this. Okay. So if I'm adding this to this is going to be this to that. But we have to do something first. Now I can write this one as 1 over x dx over y squared plus u, and I can write this one too as 1 over y dy over negative, so the negative times this will give you negative x squared negative u. You know that you can do that. Yes, you can add them like that, and this is equals to du x squared minus y squared u. Okay, I hope what I've done you understand. 1 over x is the same as writing is 1 over x. That's why I've just brought it out. Now let's add them and see. 1 over x dx plus 1 over y dy is equals to, now if you add this and this will go to 0. U minus u is 0, leaving y squared minus x squared is equals to du over, now this one can also be written as 1 over u, so that the u goes up, leaving x squared minus what? Y squared. I should have even written it here, but I forgot. Now from here, this is y squared minus x squared. This is x squared minus y squared. It has been interchanged. Okay, so I can bring negative here. Here become negative, here become plus. It's the same thing. So that we can, since the denominators are the same, now they are the same, right? We can multiply through by that and it will go to 1. Then we have only the numerator 1 over x dx plus 1 over y dy equals to negative 1 over u du. Is that okay? So in this case we can integrate. So let's integrate this one. This will give us ln x plus ln y equals to negative ln u plus ln c1. So ln xy equals to ln c1 over u. I hope you know why it's over u. This is negative, so when you are adding it will be like this. Is that okay? So when you apply the e on both sides, you are going to have xy equals c1 over u, which is the same as c1 equals uxy. So I have my first c1 equals uxy. Is that okay? Okay, now let's look at how to get our c2. You see, this one to let me do something. Let me open the brackets first, so that I have the x over, no, even if I open the bracket I won't get what I want. You see, this place is, if I multiply this by this, it will be xy squared. This will be negative y s squared. It won't be the same. If it was the same, I would just do that and add. You understand? But here, let me do something here. Let me multiply this side by x over x. So the x over x y squared plus u. Then also multiply here by y over y, multiply by dy over negative y x squared plus u. Okay, don't forget about the u for now. x times this will going to give us x dx, all divided by x times x is x squared times y squared is x squared y squared, x squared times u will be x squared u. Is that okay? Is equals to y dy over negative x squared y squared. It will be y squared times x squared. That will give you that. Oh, there's negative here. Minus u y squared. Is that okay? So this is what you're going to get. Equals to this. Okay. Now let's add and see. If you add this, you see this and this are the same. So what you are going to get is x dx plus y dy, all divided by x squared u minus uy squared is equals to du over, let me multiply the u through so that I have x squared u minus y squared u. Okay. Now is this the denominators, are they the same? The answer is yes, they are the same. Can you see that? So if they are the same, they will go to 1, leaving x dx plus y dy equals du. So this will cancel. This you integrate them. So here gives you x squared over 2 plus y squared over 2 equals u plus c2. So in this case, when I multiply through by 2 and I make c2 the subject, you see that I'll get c2 to be equals to x squared plus y squared minus 2u. Is that okay? Just multiply through by, for the c, 2 times c2 will still be 2 c2, so it doesn't matter. 2 times this will be x squared is here, 2 times this will be also y squared is here, 2 times this will be 2u. So if the 2u cancel, it become negative. Is that okay? So you have your c2 to be this, and this is our c1. If you have forgotten, u x y. Very, this is our c1, this is our c2, c1. So what you are going to do is very simple. What you do here is that you equate c1 to be equals to what? F of c2. You can also equate c2 equals f of c1 because they are all having u, so there's no problem with that. So now from here, our c1 is what? U xy equals f of x squared plus y squared minus 2u. Let's use the initial condition that was given. So this was the initial condition given. So for the initial condition, u is s squared, okay? So wherever I see u, this is a general solution, okay? Wherever I see u, I put s squared there. So I'm going to have s squared multiplied by x is x, y is what? 3x equals x is x, so s squared plus, here will be 3x to the power 2 minus 2s squared. This will be 3x to the power 4 equals this 3x all to the power 2 will be 9s squared, okay? Plus this, that will be 10 squared minus 2s squared, that will be 8x squared, okay? That's what we are going to get. So you just have to say that let p equals 8x squared. Then you divide here by 8, here by 8. So that I have x squared equals p over 8. But I want only x, not x squared. So it takes square root. So our x will be square root of p over 8. So this is what you're going to get for our x. Okay. Let me write the general solution here. If not, I might forget. The general solution was given as u xy equals f of x squared plus y squared minus 2u. So this is the general solution. So I'm going to use it. So now f of now 8x squared is now we are saying that f of p. So whenever you see x here, you should put square root of p over 8 there. So we are going to have, there's 3 already outside, so 3 square root of p over 8. This is what you are going to get, okay? So here, this will give us f of p equals 3 bracket open p squared over 64. I think this is how it's going to look like, because the square root is like p over 8 all to the power half times 4. So this 2 goes here, leaving 2. I got p over 8 to the power 2 like this. So that is correct. So now when you come to the general solution, we want to remove this f here. So now this x squared plus y squared minus 2u will be equals to 3 bracket open. Now the whole of this p is x squared plus y squared minus 2u all squared divided by 64. So let's come back to this place. U xy equals f of x squared plus y squared minus 2u. And the whole of this is now this one. So we are going to have u xy equals 3 bracket open x squared plus y squared minus 2u all squared divided by 64. So if I want to make u the subjects in terms of x and y, we have 3 x squared plus y squared minus 2u all squared all divided by 64 xy. So this becomes our particular solution, and this is a general solution. So the idea was that we wanted to remove the f from there. Is that okay? Yes. So it's not easy, but you need to continue doing it. For you to become perfect, you have to continue trying. Thank you very much for watching.